On my last video, I talked about sine x, cosine x, their properties, and how to graph. Now I'm going to do same thing about tangent x and cotangent x. So first of all, we know that tangent x is equal sine x over cosine x. And right away we have to look at the case when cosine x is 0, because cosine x cannot be equal 0, because at the point of 0, when cosine x is 0, tangent x is undefined. Okay, so let's see, when on unit circle, at which point cosine x is gonna be 0. So cosine x is, as we know, represented by x axis. So here it is, cosine x. This is our cosine x. And sine x represented by y. I'm sorry, represented by y. So let's look at cosine x. At what point cosine x turned to 0? Because cosine x is nothing else but our x. So it's going to be 0 at the point of half a pi, right? Because x here is 0. And at the point of negative half a pi. So what's going to happen at this point? At the point of positive half a pi and negative half a pi, our tangent is undefined. Therefore, undefined meaning here it's becoming as asymptote, vertical asymptote, positive half a pi, negative half a pi. Okay? So, let's see. From 0 degrees, and this is our 0 degrees, let's see what's happening. From at 0 degrees to half a pi, our tangent x, it's going to follow our sine x from 0 to half a pi. Let's see on this area. Sine x is growing, right? From 0, because in numerator we have sine x, so tangent going to follow sine x. So at the 0 degrees, sine x is 0, because our y is 0. At the point of half a pi, the sine x is going to be 1, because the y is equal 1. So what's happening? It's moving from 0 to 1, right? Or it's going from 0 degrees to half a pi degrees. Here's from 0 to half a pi. But it's never crossed half a pi because it's not identified half a pi, okay? So let me clean here this point. Oops. Okay. Well, that's okay. And at the point from negative half a pi to 0, it's going from negative 1 to 0, right? Which is from negative pi over 2 to 0, which is going here from negative pi over 2 to 0. There we go. And here we get our tangent x. Okay, so let me take in, here is based on unit circle. This is what we get. Okay, and further, that since it will make 1 pi, from negative half a pi to positive half a pi is 1 pi. So it can repeat, the graph can repeat it because it's periodic, because sine x also periodic. It's going to repeat itself every single pi. So here it is. From 0 to this point 0, we have here pi, right? This is our pi. And then from 0 going towards negative, we get negative half a pi, right? And so on. And you can continue by pi, which is the period is 1 pi. So let me see. This is our period, and it's going to repeat unlimited as long as you go repeat it itself in 1 pi. Okay, so this is our tangent, the graph of tangent. Next, let's explore some properties here. So let's take tangent at the pi over 4, 45 degrees. So it's going to be equal sine pi over 4 over cosine pi over 4. Yes? Okay. That is going to be equal, because it's 45 degrees. It's right here, 45 degrees. So it's going to be n sine and cosine going to be equal, which is square root 2 over 2. Here also cosine square root 2 over 2. So we are dealing with tangent in the first quadrant. Let me write down first quadrant, second quadrant, third quadrant, and fourth quadrant. So in first quadrant, x is positive, y is positive. Therefore, cosine is positive, sine is positive. And we are getting 1. Okay, now let's take tangent negative pi. Actually, let me write down tangent pi over 4 is equal 1. Okay, now let's do tangent negative half a pi, pi over 4. So if I take tangent negative pi over 4, it's a negative 45 degrees. So negative 45 degrees, it's going to be this way, right? Because angle will go clockwise. Negative 45 degrees. In the quadrant 4, which is the negative 45 degrees, in the fourth quadrant, we can say that y is negative, right? Here y is negative, and x is positive. Therefore, we are going to get here y is going to be negative square root 2 over 2. Cosine, it's going to be positive square root 2 over 2. And we are getting answer negative 1. Okay, so let's do this. Take our tangent pi over 4 equal 1. I'm going to multiply by negative 1. Why? Well, as long as you multiply both sides of equations, you can multiply by any number you want. And I'm multiplying by negative 1. Because I want to explore if the function is odd or even. So what do we get here? We get negative tangent pi over 4 is equal negative 1. Yes? Is equal negative 1. Okay? So, what can we say about it? If negative tangent pi over 4 equal negative 1 and tangent negative pi over 4 is equal negative 1, if in a case of two equations, if left sides are equal, that means right sides also have to be equal, correct? Therefore, I can write down negative tangent pi over 4 is equal tangent negative pi over 4. Or vice versa. Doesn't matter. Tangent negative pi over 4 is equal negative tangent pi over 4. So, and we know based on if function is odd, then what do we have? F of negative x is equal negative f of x. This is a property of odd function. So can we insist that our function is odd? So tangent x is odd function. Okay. So since it looks like we started already exploring our properties, let's might as well start writing down properties. So let's start with domain. What values can have x? X can be any degree, but which one we said cannot be? Half a pi? Negative half a pi, correct? Half a pi, negative half a pi, and then repeating by pi itself. So domain can be anything but half a pi plus n times pi, where pi is a whole number which can be positive and negative, right? Range. In the case of range, we don't have any limitation. It's from negative infinity, it's running from negative infinity to positive infinity. So negative infinity is when we have negative half a pi, positive infinity when we have positive half a pi, and every single periodic at every single time we can repeat every pi. So it's gonna run negative infinity to positive infinity. Okay, domain, range. Now let's look at zeros when we get tangent 0. Tangent is gonna be equal 0 when sine is gonna be 0, right? Because you have to have sine has to be 0, so in this case sine has to be 0, so tangent will become 0. So at what point sine will be 0? Sine is going to be 0 at the point of 0 degrees, pi degrees, and then again 2 pi degrees, and then 3 pi degrees, and then 4 pi degrees. So every pi, 0 and plus pi, and n times pi, which is going to be our y is going to be 0, which is going to be our cotangent, when x is equal n times pi. I don't want to write down 0 plus n times pi. Okay, because if n is 0, then we get that 0. The fourth property, period. Period we already know, it's 1 pi, right? We talked about it. Okay, function is odd, we already talked about it. Odd, tangent negative x is equal negative tangent x. We also know about it. increasing. Okay, if I have the numbers of line going from left to right, yes? So from negative half a pi to positive pi, do you see anywhere is decreasing? So first it's coming from negative infinity to 0, and then from 0 it's going to 1, or positive infinity degree wise. From the point of y, it's going from negative 1, this is negative 1, it's going from negative 1 to 0, and then from 0 to positive 1. So it's increasing throughout the period. Or it's increasing from negative half a pi to 0, or from 0 to half a pi. On some graphs, you will see x marked down as pi for in the degrees. In some ones, you will see marked down as 0, 1, 2, 3, 4, because it's marking down with a value. Okay? Okay. So, what do we have? So throughout the period, it's increasing. The graph is increasing. When I say 0, 1, 2, 3, 4, that's going behind of unit circle, right? So any trigonometric circle instead of unit. So it will keep, because it's repeating itself, it will keep going. So I don't want you to get confused. Because unit circle is running within one radius 1. Okay, it's increasing because our period from negative pi to negative half a pi to positive half a pi. So it's going to increase from negative half a pi, increase to positive half a pi. And then negative half a pi can increase, can repeat itself every pi n times, as many times as you want. And positive half a pi can repeat itself through every pi or n times pi, as many times as we want. Okay, and last one, we're gonna look when tangent is negative, when tangent is positive. Tangent x is positive. Let's see. If you look at this graph, we're on the interval between 0 to half a pi, correct? And so it is positive. All right? And it's going to be negative from negative half a pi to 0. Why? Because it's below 0. Graph is below 0, so it's negative. And above 0, it's going to be positive. So from 0 to half a pi, it's positive. From negative half a pi to 0 is negative. So let's mark this down. It's greater than 0 at the point from 0 to half a pi. Let me write down 0 and half a pi. And 0 can repeat itself every pi or n times pi. And plus also pi or n times pi. So 0 here I can clean, correct? Okay. And will be n pi and half a pi plus n pi. Or if you want, you can leave it 0 there, so if it's easier to read for you. Tangent x less than 0. When did we say? From negative half a pi to 0, right? It's going to be negative half a pi. Here is 0. So it's going to repeat every pi times or n times pi and plus n pi again. Or we can take this 0 away, and it's going to be from negative half a pi plus n pi and all the way to n pi. So these are properties of tangent. Moving to cotangent. Cotangent is equal cosine x over sine x. So since we have fraction and in denominator we have sine x, that means right away we put condition sine x cannot be equal 0. Let's see it, which means what x cannot be. X cannot be where sine x is becoming 0, at the point of 0 and pi. And then again 2 pi, and then go back again 3 pi, and so on. So it can be 0 plus n times pi. So 0 I'm not writing, we put n times pi. So that means that at the point of 0, pi, 2 pi's, 3 pi's, negative pi, negative 2 pi, we are having asymptotes here. Here it is. And for negative pi, I can put also, those are asymptotes. Now, cotangent follow cosine as to increasing, decreasing. So from 0 to half a pi, my cosine is increasing, yes? I mean decreasing, I'm sorry. Is decreasing. Why? Because from 1 goes to 0. Cosine here at the point of 0 degree is 1. Moving to half a pi, it's become 0. Okay, so from 0 to half a pi is decreasing. Therefore, cotangent also decreasing from 0 to pi. Here it is. Now, from half a pi to pi, it goes from 0 to negative 1, so it continues decreasing further. So from half a pi to pi, it's continued decreasing, which means our graph cotangent x decreasing throughout the whole time period. When time period is from 0 to pi, which is 1 pi, correct? Here it is for unit circle. So cotangent, while tangent is increasing, here it is on its unit circle time period, and according to that will increase on any time any n times pi period. So same thing is here, at any n times pi period it's going to decrease, and period as we can see is 1 pi. Let me invite your attention. Look what's happening. Tangent is changing from negative half a pi to positive half a pi. Cotangent is changing from 0 to pi. So it looks like tangent and cotangent are shifted from each other by half a pi. We will explore this in further upcoming videos. Okay, so the same way now, if we explore odd or even, it's going to be the same way as a tangent we did, which means I'm not going to do the same thing twice. With the difference is cosine square root 2 over sine square root 2. From here we can also conclude that cotangent is also odd function. So, like I said, odd one, it sounds like bad one. No, it's only odd. So let me write down cotangent negative x is equal negative cotangent x. Now, just to show you here, look, it's running tangent, while tangent on this picture is running from negative half a pi to positive half a pi. Tangent is running from 0 to pi, and you can see the shifting also. And down the road, I'm going to explain why it is negative, because we need to learn the formulas of trig functions before I can explain this to you, okay? But it will be there, explanation, why it shifted. So cotangent is negative x is equal negative cotangent x. Okay, let's also explore domain and range. Okay, so what is happening to domain for cotangent? The cotangent x for domain x is can be any value but 0, pi, 2 pi's, negative pi, so based on a period change. Okay, so domain cannot be n times pi. Range is running from negative infinity to positive infinity, right? From negative infinity to positive infinity. There is no break in there. Zeros. At what point we have zeros? Zeros we have at the point half a pi, 3 over 2 pi, which means difference between them is a pi, right? Okay, let me show. Here it is. This is your period. It is 1 pi. Okay, so 0 it's going to be from half a pi plus n times pi. So that's going to be your 0. All right, what else we have? Period. Period, we know it's a pi. Let me write down for tangent also pi. Okay. Odd, yes, we know its function is odd. Where is it increasing, where it is decreasing? We already showed that cotangent x is decreasing throughoutly from 0 through pi, which means that any other pi times n period, it's going to only decrease. And while tangent is only increasing. And we will also, let's look at when cotangent is positive, when cotangent is negative. So cotangent is positive where? When it's above 0, which is going to be from 0 to half a pi, right? And plus every pi, n times pi, repeated times. And it's negative from positive half a pi to pi, because it goes below the graph, right? From positive half a pi to pi. Here is blue color. This is negative there, where it is negative. So it will be half a pi plus n times pi, and all the way to pi plus n times pi. Okay, let's now summarize these properties we just mentioned. So first one, domain. Domain, we said x cannot be equal n times pi. Again, pay attention. For tangent, it's pi over 2 plus n pi. Here is 0 plus n pi. So shift it by half a pi. Number 2, let me move it here because here I have, okay. Number 2, range. Range is again, it's running from negative infinity to positive infinity. I already said that, we looked into that. Zeros. So when do we have 0? We looked into that when y is equal 0, when x is equal half a pi plus n times pi. Remember? Cotangent. This is my half a pi, right? And plus n times pi. Number 4, period. Period, we already looked, it's 1 pi. Now, odd. Obviously, cotangent also odd. Cotangent negative x is equal negative cotangent x. What else we have? Increasing. So we saw that increasing, decreasing, while tangent is increasing, cotangent is decreasing throughout the 0 through pi period. This is our 0, this is our, okay, it's supposed to be, this is our pi, so it's decreasing, right? So it's decreasing when from 0 to pi, correct? Which means if you go by period, n times pi, n plus n times pi. Okay, I'm cleaning here 0 and bringing this back. Okay, we got n pi and pi plus n pi. Number 7. 7 is where it's positive, where it's negative. So cotangent x greater than 0. When did we say it's positive? This piece, right? Remember? From 0 to half a pi, because it's above the graph. So it's going to be from 0, then I don't put 0, half a pi, so plus n pi. Here also will be just the n pi. And less than 0, whenever it's in the area where it's below the graph, which is going to be this one, right? So from half a pi to pi. So it's going to be half a pi to pi. Oops. And plus n times pi. And plus n times pi. Okay? All right. I'm done with tangent and cotangent, and I see you in next recording. I don't know what's going to be, but I definitely will record something that is really important for students. All right? Okie dokie.